Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris bin HAZBAN. My student ID is 2020815156. So I have given a mini project by my lecturer, which is Sir Mustaqimuddin, to do 5 experiments for this mini project, which is moisture content, particle density, permeability, field density, and sieving. So the introduction for this mini project is students are required to finish up this assessment they call mini project. This mini project is about conducting 5 experiments. There are related soils, which are water or moisture content, particle density, particle size, grading and texture, field density, and permeability. Students are required to make a video and report in order to accomplish the task given. For the objective of this mini project, the objective for this mini project is to collect soil sample and conduct soil experiment in the laboratory or site field. Before conduct experiment, make sure we know what we must achieve during this experiment. Make sure we fully understand all the needs needed, such as procedure, how to obtain the data, and especially the result for us to conclude this and summaries. For the background of study, the experiment that we conduct is a friendly experiment, which means we are able to conduct everywhere, even we are at home. We still can get result even we do not use laboratory equipment. For this 5 experiment, we do not have to spend so much money in order to accomplish these experiments. It takes less than 4 kilograms, and we can use the recycled things as an apparatus to conduct this experiment. In this way, there is no reason to do not finish up this mini project. The moisture content of soil, also referred to as water content, is an indicator of the amount of water present in soil. Moisture content is the ratio of the mass of water contained in the pore space of soil to the solid mass of particles in that materials, expressed as a percentage. This test is performed to determine the moisture content of soil. This test is performed to determine the specific gravity of soil using density bottle. In this laboratory activity, students will be exposed to the uses of sieving test to determine the particle size distribution of soil. Dry sieving was used to determine the size of adhesiveless soil containing sand and gravel only. This test is performed to determine the percentage of different grain size contained within a soil. The dry density of compact soil or pavement is a common measure of the amount of the compaction achieved during the construction. Knowing the field density and field moisture content, the dry density is calculated. Therefore, field density test is important as a field control test for the compaction of soil or any other pavement layer. This test is performed to determine dry density, PD, of in situ soil. In this laboratory session, students will be introduced on how to determine the coefficient of permeability of soils using falling head test. This test is performed to determine the coefficient of permeability of fine-grained soil. Warahmatullahi wabarakatuh. Today I will conduct an experiment which is moisture content. So the apparatus for this experiment is, first we need can, and then we need electrode balance, and then the soil sample. And then for the procedure, the first step is we need to weight this empty can. And then we take the reading of the weight. Repeat this step for the second can and third. Okay, and then we take the soil sample into the empty can, and then we weight the weight for the can plus soil sample, and then we take the reading. We need to repeat this step for the second and third can. Before we weight the soil sample and can, don't forget to press the don't forget to set 0 to avoid the parallax error. And then we put the soil sample into the oven. After 1 day, we will weight the soil sample weight, and then so we can get the data of the moisture content. The apparatus for the experiment is distilled water, density bottle with stopper, size sample, balance, and then vacuum set, and then the last one is temperature. First, we need to clean and dry this density bottle with stopper properly. And then weight the right bottle with stopper and record the mass, which is M1. And next, pour 10 until 20 grams of oven dried soy into the density bottle. And then weight bottle with soy and stopper, record the mass. Pour about 10 ml distilled water, leave it for 2 until 10 hours. And then pour some distilled water until half full. And then put the bottle into the vacuum to remove the trapped bubble. After that, pour some distilled water until it full without any trapped bubble. And then weight the bottle with water soy and record the mass. After that, empty the bottle, fill the bottle with distilled water and record the mass, which is M4. Repeat again all the steps for 2 observations to obtain average, which is GS. This is the data that we get from particle density experiment, which is I get average for this experiment is 2.55. This is the sample calculation of specific gravity, which is M2 minus M1 over M4 minus M1 minus M3 minus M2. The apparatus for the experiment is refill box, lid of and receiver, brush, set of sieve and soil specimen, and balance weight, and the last one is mechanical shaker. The procedure for this experiment is, first we need to prepare the soil sample 1 until 2 kg, and then we need to clean and weight each sieve to be used in this experiment. Next, we need to arrange the sieve in order the largest opening at the top and the smallest at the bottom, and then place pen below the smallest sieve and cap over it. Next, pour 2 kg of soil into the sieve that need to be used in the stage 1, and then after fill it with the soil, put in the mechanical shaker for 10 minutes. Next, take the retained soil into refill box to divide into 2 parts. Next, take 1 box only of the refill box and use it back for stage 2. Make sure take the correct sieve. Next, we need to turn on the mechanical shaker for 10 minutes. Repeat again step 6 until 8 for the stage 3, and then record the data. This is the data that I get from this particle sieve distribution experiment, and this is the graph, which is clear 0%, sand 54% and gravel 44%. And this is the sample calculation for this experiment. The apparatus for this experiment is set of pouring cylinder and Ottawa sand. For the part A, we need to determine the density of sand to be used using calibration cylinder. And next, determine the weight of cone that will produce under the pouring cylinder by determining the weight of that cone produced. For the part B, first make sure the side is clean by using scraper. Then use metal tray central hole is placed on the prepared surface. Next, use the hole pattern to excavate by using a trowel. Next, use the sand pouring to fill up the hole. And then the metal tray is removed and the sand pouring is placed center over the hole. Then, weight again the pouring cylinder. The moisture content of excavated soil is determined by taking the soil sample from its moisture content dish weight. Repeat the steps 3 times to get the average value. This is the data for the experiment, which is part A calibration stage and part B field result. This is the sample calculation for calibration cylinder, which is density of pouring sand, and sample calculation field result, which is moisture content of removed soil. The apparatus for this experiment is stands part, bucket, sample extruder, the compaction mold, the thermometer, and the stopwatch. Next is the procedure. First, we need to take U100 sample from a coagular tube. Second, place the soil sample fully through triangle sand on top of porous stone and place again on top of soil sample. 3. Place the whole setup bucket partially submerged in water. 4. Measure the length and diameter. Record the diameter of standpipe. 5. Connect the standpipe to the sample. 6. Open the valve and feed the water into the standpipe to initial mark height. 8. Record head, which is H1, and time, which is T1. Next, close the valve and start the time to observe and record the temperature. This is the data that we get from this experiment, which is overall average coefficient of permeability of soil sample, which is we get 5.665 times 10 to the power of -4. Next is the sample calculation for this experiment, which is the coefficient of permeability of soil and overall average coefficient of permeability soil sample. For the discussion, we learned how to apply on the new formula that we were first time using it. Even though it was a little bit difficult to understand it, but we managed to apply in a correct way. We also learned how to plot on a new graph and how to calculate the data based on data given. For the moisture content experiment, we know that there must be error while doing it. In order to get the best quality while conducting the experiment, we try to avoid the errors. This experiment is about to get the determination of moisture content. Based on result we obtained, we get an average after 3 sample specimens were collected with 85.03% of the last average. The first calculation for moisture content was 85.72%. The second calculation was 84.93%, and the third was 84.44%. Based on this experiment, the sample given is fine-grained soil, so the density bottle method was carried out. The density of soil solids is obtained using the specific gravity of the solids. The result is achieved by multiplying the basis weight of the sample with the density of water with the non-specific density of the soil enabled the engineer data on the porosity of the soil sample and the voids involved in the method implementation. It also benefits the engineer to determine whether the soil is suitable for their design. The higher the specific density, the higher the durability of the building material. For the result of this experiment, there are 3 determinations by using the density bottle method. For the first test, the specific gravity is 2.57, the second test is 2.52, and lastly the third test is 2.56. Furthermore, the average specific is 2.55. This laboratory is used to determine the proportion of different grain size in a soil. So test sieve shakers were used in expressing the percentage of the total dry weight. It involved shaking a soil sample through a series of sieve with increasingly smaller plates. Not only that, sieve analysis typically represent a percentage of the total weight of soil that went through each sieve. The experiment's error will calculate by calculating the difference between the end total mass and the beginning mass of the soils for each experiment. It was calculated by the initial and final masses of the soils. Since the errors the experiment are accepted, the cumulative percent retained in each sieve are equal to the sums up of the percent of retained using the equation. Data were required as in the result. In this laboratory, we conduct field density by sand replacement method. We compare the dry density in this laboratory. Dry density is a compact soil of compaction achieved during construction. To identify field density, we need to measure moisture content and dry density. We conduct 2 activities in this laboratory, which is to conduct sand by replacement method and determine the field density of soil. We conduct the laboratory based on the lab manual. All the readings were recorded and tabulate in the table. We calculate the reading so we can calculate the density of pouring sand, which is the mass of sand inside the cylinder divided with the volume of the calibration cylinder. We calculate the density of pouring sand and get 1,351.28 kg over meter cube. Meanwhile, to calculate moisture content of removed soil, we need to know the value of wet weight known as W and weight after drying known as D, because the formula we use to calculate moisture content is W minus D over W times 100%. We calculate the moisture content and we get 3.58%. In this laboratory, we need to determine the coefficient of probability of fine-grained soils, such as silt and clay. Probability is defined as the capacity of soil to flow through the voids and the flow of velocity according to a hydraulic gradient of unity. In this laboratory, we use the falling head test to determine the coefficient for fine-grained soils, not using constant head. For coefficient of fine-grained soils, the coefficient are too small, and if we use constant head test, the readings will not be accurate. Falling head tests are governed by Darcy's law. In conclusion, based on these 5 experiments that we conduct in this mini project, we already have the basic knowledge based on the calculation and how to execute these 5 experiments. This is because we apply back all the basic knowledge on this past few semesters that we have learned. We also gain new knowledge and be more sensitive towards certain apparatus in order to take care of it. The advantage that we could get from this mini project are having a deep understanding of the types of soil and how they behave is therefore important in such as excavation activities. Next, soil mechanics can help an engineer anticipate areas that may cave in or cause landslide during the research extraction and come up with appropriate way of preventing such disastrous incidents. Lastly, soil mechanics is very important for all civil engineers. By understanding various soil properties and further as well as behavior, you can eventually provide practical and feasible solution towards various engineering problems to ensure that your structure continues to stand strong at the end of the day. That's all from me for my video for this mini project. Thank you.